Okay, C was said to revolve around the x equals 0. So we're revolving on this line. So it's going to go like this way. So since we're revolving this way, it's going to be in terms of dy. Okay. Again, in this case, we need to look at what the radius will be. Okay. In this case, this is our radius right here. How do I get the radius? That radius is going to be, this is 3. Okay. That is 3 minus the function.
April Orona.
Sorry.
Portable 15.
Okay, so here we go. So it's going to be 3 minus a function is going to give me this little piece right here. So that's why it will go from, it will be pi 0 to square root of 3. And our radius will be 3 minus y squared squared. To get this piece is going to be 3 minus the function. 3 minus the function. And then, so we need to square that. We need to distribute that. When we distribute this, we get the 9 minus 6y squared plus y to the 4th. Again, we need to distribute, which means we need to write it like this and distribute. And then we take the integral and we plug in the square root of 3. You can plug it in like this and wipe a sign. It will accept it as a correct answer. You don't have to simplify all the way. Okay, there's different ways that it will count it as correct. The next one, it revolves around y. Okay, this is the picture and this is x equals y, goes around this way. What is going on here? There's going to be a hole. So this piece is going around this way, going on like this, but there's going to be this hole in the middle. Okay, there's going to be that hole in the middle. So what are we going to do? So in this case, we have a big radius, okay, minus the small radius. So I gotta do from here to here, I gotta do this one right here, minus the hole. This is my hole. So what are we gonna do? So similar to the one earlier, but now, okay, this right here is the radius we got earlier. Remember that it was a 3 minus the y squared, okay? So we're adding 6 because from here to here, there's 6 units. From here to here, there's 6 units. And that's where they're adding that 6 to the radius. The whole. This is the whole that we need to get rid of. That is just 6. So we're doing the radius, we're doing this right here. This is the radius we're getting, the first radius, minus the radius of the whole, minus the radius of the whole. That's where that comes from. And then we distribute and simplify and take the integral. The important thing here is the setup, okay? Is the radius, the bigger radius, minus the whole. Okay, so we're going to do shell method, 7.3. So here what we're going to do, remember for shell method is a 2 pi. It's revolving around the y-axis, so we're going to do it in terms of x. So it's going to be from 0 to 1. Those are the limits. So remember here we have the radius times the height. In this case, the radius, which is p of x, will be x. It's just like where are we on the x values, the x-axis. The height is going to be determined by the function, and in this case, my function is y equals the square root of x. And that will be my h of x, or my height. So we're going to have x times the square root of x dx, okay? This is exponent 1, 2, and we can rewrite this one as an exponent as x to the 1/2. If we have the same base, we can add the exponent. So that's going to be a 2 over a 2, and it's going to become a 3/2. Remember that to integrate it, we need to add 1 to the exponent. So again, we add 2 over 2, and that's going to give me 5/2. And then we multiply times the reciprocal, which is going to be 2/5. We evaluate from 0 to 1. So then we have 4 pi over 5. This is going to be 1 to the 5 over 2. And that's just going to be 1. And that's where they're getting the answer 4 pi over 5. Okay. This next question is rotating around the x-axis, is rotating this way. But since we're doing the shell method, it's going to be in terms of y. So I got to solve for x. So x is going to be equal to 4 minus y squared. Remember, we have the 2 pi. In this case, my limits are from 0 to 2. And here, my radius is going to be y. My height, so radius is going to be y depending on how high it is. Height, this is going to be my height. It's going to be depending on the function. So it's 4 minus y squared. So what we're going to do, we're going to distribute. So 4y minus 4y squared dy. And we're going to integrate it. So we're going to get y squared 4 over 2 minus 4y cubed. Hold on. When we distribute this right here, that becomes a 3. So when we integrate, this becomes a 4 over 4. So then if we simplify, we have 2 pi. And then, are we integrating already? We're integrating already. It's going to be 4 divided by 2 will be 2y squared minus y to the 4 from 0 to 2. So in reality, we just need to plug in the 2. Okay, after simplifying, my answer is going to be 8pi. Okay, this next one is 4.7, and it's talking about arc length. Remember that there was a specific formula for arc length. It's going to be the limit. In this case, it's going to be in terms of x. So it's going to be from 0 to 2. From 0 to 2. This is going to be the square root of 1 plus the derivative of the function squared and dx. Okay. So in this case, we have our function. And we need to take derivative of this function right here. To take the derivative of this function, we bring the exponent down, which will be 3/2. And then we subtract 1, which is going to be 1/2, times the derivative of the inside. That cancels. So we are going to have the square root of x squared plus 1 times 2x. So it's going to be from 0 to 2. 1, and then we need to square this. So when we square this, the square root and the square cancels. So we have x squared plus 1. This one becomes 4x squared. So we need to simplify. That. So when I distribute this one times this one is going to be 4x to the 4th plus 4x squared plus 1. It's underneath the root. This right here factors to 2x squared plus 1 to the squared. When we do that square root squared, it cancels. So we're left with 2x squared plus 1. From here, we integrate. So it's going to be 2x to the 1/3 over 3 plus x. From 0 to 2, when we plug in the 0, it goes away. So in this case, we have 22 over 3 as my final answer. For the surface area, we're going to add the 2 pi. In this case, the limits are from 0 to 3. We have the function in the outside times 1 plus the derivative of this squared. Again, y prime squared. So we're adding the function in the front for the surface area and the 2 pi in the front. In this case, to get y prime, we put down the 3 and the 3 over the 3 cancels. We subtract 1 and we get x squared. X squared, which is going to turn into x to the 4th power. So 0 to 3, 1/3 x cubed, 1 plus x to the 4th x. This is what we need to integrate, okay? Remember, we use substitution, okay? Let me get paper. So in this case, I will let you my 1 plus x to the 4th be 4x to the 3rd dx. We have the x to the 3rd and we have the 4th. So 1/4. So 1/4 du equals x cubed dx. I'm going to take that 1/3 also outside. So it's going to be 2 pi over 3 from 0 to 3. Instead of this, so it's going to be u to 1/2 du, and I'm going to add the 1/4. Sorry, I'm going to add the 1/4 and the outside multiplying. So the integral of this, remember, I'm going to add 1, which is going to be 2 over 2, which is going to be 3/2. Multiply times a reciprocal, which is going to be 2/3. And then I still have all of this. I have the 2 pi, the 3, and the 4. Multiplying. All of that multiplying. And then so I have the 2 and the 2 would be 4 pi. So that 4 and that 4, well, you'll see right now. 3 times 3 is 9, times that 4, the 4 cancels. So we have pi over 9. Instead of u was 1 plus x to the 4th. That to the 3/2. And this goes from 0 to 3. Plug in the, we plug in the 3 and the 0 because there's a 1 right there. So we're going to plug in the 1 plus 3 to the 4th power. This to the 3/2 minus 1 plus 0 to the 4th power to the 3/2. Okay? Simplify, and that will be our answer.